Welcome, traveler. Tonight, I invite you to leave the noise and the light of the surface world behind. Close your eyes, let your shoulders drop, and take a slow, deep breath in and out. We are beginning a journey into the quiet, the dark, and the still. We are going deep beneath the earth's surface, to the silent places where beauty doesn't rush, but grows with a steady, ancient patience. As you lie there, imagine the ground beneath you. We often think of the earth as a solid, unchanging mass of stone, but it is much more delicate than it seems. If you were to look at the earth from space, the crust, the very ground we walk upon, is surprisingly thin. Scientists often compare it to the skin of an apple. It is a fragile protective layer wrapped around a world of heat and mystery. Just a few miles below your feet, the world begins to change. The air disappears, replaced by the heavy, comforting weight of stone. It is in this darkness, between 3 and 25 miles deep, that most of the gemstones we treasure begin their lives. In these hidden nurseries, minerals move and shift, searching for the space to become something more. But some treasures require a much deeper solitude. Diamonds, perhaps the most famous of all stones, do not form in the shallow crust. They are born much deeper, nearly 100 miles down, in the vast and glowing layer known as the mantle. At these depths, the environment is unlike anything we know. The weight of the world above is immense, and the temperatures are staggering, often reaching over 2,000 degrees Fahrenheit. It is easy to imagine such heat and weight as destructive, but in the heart of the earth, they are creative forces. Intense pressure is the primary sculptor of the underground world. It doesn't just crush, it organizes. It pushes atoms together with such incredible force that they have no choice but to lock into the perfect repeating patterns we call crystals. It is a slow, rhythmic process of transformation, turning common elements into extraordinary structures. As we continue our descent into these quiet depths, I invite you to softly subscribe to this channel and join our community of quiet learners. It is a simple way to ensure you can always find your way back to this peaceful place. For now, just settle in. Let the weight of your blankets feel like the protective layers of the earth, and let yourself drift toward a long, restful sleep. Down here, far below the wind and the rain, the concept of time begins to stretch and change. Up on the surface, we measure our lives in minutes and hours. But in the deep, dark places where beauty grows, time is measured in something much larger and much more patient. Under the immense weight of the mantle, a single moment can last 1,000 years, and the silence is as thick as the stone itself. Imagine, for a moment, being surrounded by that total heavy darkness deep within the earth. There is no sun to mark the days, no moon to pull the tides, and no wind to rustle the leaves. In this place, time does not tick away in seconds or minutes. It flows like a deep, slow river, stretching across eons that we can barely begin to comprehend. In this stillness, beauty is never rushed. Some of the most magnificent crystals you might imagine take millions of years just to grow a single inch. To put that into perspective, in the time it takes for a vast mountain range to rise and be worn back down to hills by the rain, a crystal in a quiet pocket of stone might only add a few thin layers to its structure. It is a level of patience that is almost holy, a steady, unwavering commitment to becoming something perfect. The demons that eventually find their way to the surface are perhaps the greatest time travelers of all. Scientists estimate that the oldest diamonds are about 3.3 billion years old. That is an age so vast, it is difficult to wrap the mind around. These stones were already ancient long before the first dinosaurs walked the earth. They were formed when the planet was still young, and they have sat in the silent, pressurized dark of the mantle for nearly 3/4 of the Earth's entire history. They are tiny, sparkling witnesses to the very beginning of our world. This incredible growth requires a very specific kind of environment. Crystals are born from change, but it must be a change that happens with agonizing slowness. They often grow when mineral-rich water or molten magma begins to cool. If that cooling happens over thousands or even millions of years, the atoms have the time they need to wander through the liquid, find their companions, and settle into a beautiful, organized dance. However, if the Earth rushes the process, the result is quite different. If magma is suddenly thrust toward the surface and cools too quickly, perhaps in the span of a few days or even hours, the atoms are caught off guard. They don't have the time to organize themselves into the repeating patterns of a crystal. Instead, they freeze in a chaotic, random jumble, resulting in what we call volcanic glass or obsidian. It is smooth and dark, but it lacks the internal geometry that gives a gemstone its soul. Even the very ground we walk upon is participating in this slow, rhythmic movement. The great tectonic plates that make up the Earth's crust are constantly shifting, though we rarely feel it. They move at roughly the same speed that your fingernails grow. It is a constant, subtle migration of continents, pushing and pulling, creating the heat and pressure necessary for new minerals to form. Everything beneath you is in a state of quiet, steady transition. As you focus on your breathing, let your thoughts drift from these vast expanses of time down to something much smaller, but no less miraculous. We have looked at the millions of years it takes to build a stone. But now, let's look closer, past the rough edges and the deep colors, into the hidden world of the atoms themselves. Even in the darkness, there is a secret geometry at work, an invisible blueprint that dictates every curve and every facet of the gems we admire. Imagine you could shrink down, becoming smaller than a grain of sand, smaller than a speck of dust, until you were small enough to stand between the very atoms that make up a gemstone. In this microscopic realm, you wouldn't find chaos or a random jumble of particles. Instead, you would find yourself standing in a vast, silent cathedral of light and symmetry. This is the hidden geometry of the mineral world, a secret architecture that exists in total darkness deep beneath the Earth's surface. A crystal is defined not just by its color or its shine, but by its highly ordered microscopic structure. While most things in our world are a bit messy and irregular, a crystal is a masterpiece of precision. Every single atom is exactly where it is supposed to be, held in place by invisible forces that act like the steady hands of a master builder. This incredibly organized arrangement is what sets a true mineral apart from a simple rock or a piece of glass. As you visualize this inner world, imagine a great repeating pattern that extends in every direction. This structure is what scientists call a crystal lattice. The word lattice might make you think of a garden trellis, with its crisscrossing wooden laths supporting climbing vines. In a gemstone, the lattice is a three-dimensional framework, a scaffolding made of atoms. It is a beautiful rhythmic repetition that goes on, perfectly consistent from one side of the stone to the other. Within this lattice, atoms find their places like the pieces of a perfect puzzle. When a gemstone is forming in the heat and pressure of the earth, the atoms are moving through a liquid or a gas, searching for a home. As the environment cools or the pressure shifts, they slow down. One by one, they click into their designated spots in the lattice. They don't overlap and they don't leave gaps. They settle into a state of perfect balance, finding a sense of rest and stability that will last for millions of years. There is a profound peace in this kind of order. It is an environment where nothing is out of place, where every connection is intentional. And what is truly remarkable is that this internal order dictates the external shape we see with our eyes. If the atoms inside a crystal are stacked like tiny perfect blocks, the crystal itself will eventually grow into the shape of a cube. The sharp edges and flat faces of a raw gemstone are not carved by human hands. They are simply the outer reflection of that inner microscopic arrangement. The beauty we see on the surface is a direct result of the harmony deep within. Despite the incredible variety of gemstones found across the globe, from the deep red of a ruby to the clear sparkle of a diamond, nature is surprisingly disciplined in how it builds them. In the entire study of geometry and mineralogy, there are only 7 basic crystal systems. These are the 7 families of shape that every crystal on Earth belongs to. They are the 7 blueprints that nature uses to turn a handful of atoms into a treasure. As you settle deeper into your pillow, let's begin to explore these systems, starting with the most balanced and symmetrical of them all. It is a shape that represents strength and simplicity, a structure where every side is equal and every angle is perfectly square. This is known as the cubic system, and it is the foundation for some of the most famous and enduring stones in history. Imagine the ultimate expression of balance and stability. In the world of minerals, this is the cubic system, sometimes called the isometric system. It is a family of shapes defined by total equality. To visualize this, imagine 3 invisible lines, or axes, crossing through the very center of a crystal. In the cubic system, these 3 lines are all exactly the same length, and they meet at perfect 90-degree angles, up and down, side to side, and front to back. It is a shape where no direction is more important than any other, a structure of perfect, quiet symmetry. This internal balance is more than just a geometric curiosity. It is the secret behind the greatest strength found in nature. Diamonds belong to this cubic system, and it is this specific arrangement of carbon atoms that contributes to their incredible hardness. Because the atoms are spaced so evenly and bonded so tightly in this 3-dimensional grid, there are no soft directions or points of weakness. When you hold a diamond, you're holding a piece of the earth that has achieved a state of nearly unbreakable structural harmony. It is a fortress of geometry built atom by atom in the deep, silent heat of the mantle. Garnets also share this symmetrical, boxy heritage. While we often think of garnets as round, deep red beads, they grow in the earth as complex, many-sided crystals that all trace their lineage back to the cube. Even when a garnet grows into a shape with 12 or 24 faces, its internal skeleton remains perfectly isometric. There is a sense of groundedness in these stones, a heavy, reliable presence that comes from their sturdy, balanced construction. Perhaps the most mesmerizing example of this system is pyrite, the mineral many know as fool's gold. In the dark, damp crevices of the earth, pyrite has the remarkable ability to grow into perfect, shimmering, metallic cubes. These cubes are not polished or cut by tools. They emerge from the rock with sharp edges and flat, mirror-like faces, looking like precision-engineered objects dropped by a traveler. To see a perfect cube of pyrite nestled in a piece of rough stone is to see the mathematical precision of the universe laid bare. It is a reminder that even in the chaos of a shifting planet, there is a deep underlying order. Another member of this cubic family is fluorite. While it can take many forms, it often presents itself as an octahedron, a shape that looks like two four-sided pyramids joined at their bases. Though it looks different from a simple cube, it follows the same rules of equal acts and 90-degree intersections. Fluorite crystals are often soft greens, purples, and blues, appearing like translucent geometric ghosts in the darkness of a mind. As you breathe slowly and feel the weight of your body pressing into the mattress, imagine these perfect equal shapes resting deep beneath you. They are symbols of a world where everything is in its right place, where every angle is square and every side is equal. But nature is also a master of variation. Just as a cube represents perfect equality, a slight shift in those internal lines can create an entirely new world of form. Imagine now that we take one of those three equal axes and gently stretch it, making the crystal just a little bit taller, a little more elongated. This small change leads us away from the perfect cube and into the elegant, upright world of the tetragonal system. Imagine the perfect cube we just spoke of, that balanced, six-sided box where every side is a mirror of the others. Now, in your mind's eye, see that cube gently elongating. It is as if the earth is pulling on it from the top and the bottom, stretching it out until it becomes a slender, elegant pillar. This subtle change in geometry brings us into the world of the tetragonal system. In this arrangement, the crystal still maintains its clean, right angles, but the symmetry is beginning to shift. While two of its axes remain equal in length, the third axis, the one reaching toward the surface or deep into the earth, becomes either longer or shorter than the others. It is a slightly more complex architecture, one that allows for taller, more graceful growth while still holding on to the stability of 90-degree corners. One of the most remarkable examples of this tetragonal geometry is the mineral zircon. When you look at a zircon crystal, you see a square-sided prism that often ends in a sharp four-sided pyramid. It looks intentional, like a tiny monument carved by a steady, invisible hand. But zircon is more than just a beautiful shape. It is a silent witness to the very beginning of everything. Zircon is the oldest mineral ever discovered on Earth. Some tiny crystals, no larger than a grain of sand, have been found to be over 4 billion years old. They existed before the first life appeared, before the continents took their current shapes, and even before the moon was born from a prehistoric collision in space. They are the ultimate survivors, holding their tetragonal shape through eons of heat and pressure, acting as tiny time capsules of our planet's birth. Sharing this same geometric blueprint is cassiterite, the heavy, dark ore that is the primary source of tin. It grows in stout, sturdy tetragonal crystals that feel grounded and ancient. Unlike the bright, fiery sparkle of a diamond, cassiterite often has a quiet, resinous luster, appearing like dark honey or polished wood hidden within the host rock. These tetragonal minerals are often the children of metamorphosis. They form deep within the crust, where existing rocks are subjected to such intense heat and pressure that they don't quite melt, but they begin to change. In this slow subterranean dance, the atoms rearrange themselves into these new, elongated structures. It is a process that requires immense patience, happening over thousands or even millions of years in the absolute stillness of the deep earth. As you settle deeper into your pillow, imagine the steady, upright strength of these pillars. They are taller and more varied than the simple cube, yet they still retain a sense of perfect, square alignment. But the Earth's creativity is endless. If we were to take this tetragonal pillar and nudge it further, making every single one of its 3 axes a different length while still keeping those 90-degree corners, we would find ourselves in a world of even greater variety. This next step in our journey leads us to a structure that possesses the sturdy, reliable stability of a well-laid brick, known as the orthorhombic system. As we move further into the silence of the Earth, we transition from the square pillars of the tetragonal system to a shape that feels incredibly grounded. Imagine, if you will, the shape of a simple brick or a sturdy wooden chest. This is the essence of the orthorhombic system. In this geometry, the internal structure is defined by 3 axes that all meet at perfect 90-degree angles, just like the corners of a room. However, unlike the cube where every side is identical, or the tetragonal pillar where the base is a square, the orthorhombic system is more varied. Every single one of its 3 axes has a different length. This creates a rectangular prism, a shape that possesses a sense of ancient, unshakable stability, like a stone laid in the foundation of a mountain. One of the most beautiful examples of this brick-like geometry is topaz. When topaz grows in the dark cavities of the earth, it often forms into these sturdy, rectangular prisms. They feel heavy and cool, their flat surfaces, sometimes marked by long, delicate grooves that run vertically, tracing the path of the crystal's slow journey toward completion. While many people picture topaz as a bright sky blue gem, in its purest form, it is as clear as a drop of spring water. It is a stone of immense structural integrity, a perfect representative of the balanced, right-angled world of the orthorhombic system. Resting alongside topaz in this family of shapes is peridot, a gemstone with a color so vibrant and lush that the ancient Egyptians called it the gem of the sun. Peridot is formed deep within the Earth's mantle under conditions of intense heat and pressure that would crush lesser structures. But Peridot's story extends far beyond the boundaries of our own world. It is one of the very few gemstones known to exist in the vast reaches of outer space. Occasionally, when meteorites fall to Earth from the asteroid belt, they are found to contain beautiful, translucent crystals of peridot embedded within a matrix of iron and nickel. These cis peridots have spent billions of years drifting through the cold, silent vacuum of the cosmos. Yet they maintain the exact same orthorhombic geometry as the stones formed beneath our feet. It is a comforting thought that the same laws of geometry and beauty apply here on Earth just as they do among the distant stars. Within this same structural family, we also find chrysoberyl. This mineral is remarkably hard and durable, but it is perhaps most famous for a mesmerizing optical effect known as chatayency, or the cat's eye effect. When light enters a polished chrysoberyl, it encounters a series of tiny parallel inclusions trapped within the orthorhombic lattice. These inclusions reflect the light back in a single, sharp band that appears to glide across the surface of the stone, much like the slit pupil of a cat watching in the twilight. It is a reminder of how the hidden internal arrangement of atoms can create such a striking and lifelike dance of light on the outside. As you continue to relax, feeling your breath slow and your body settle into the mattress, imagine these sturdy rectangular forms supporting the world above. They are the bricks and blocks of the mineral kingdom, providing a sense of order and permanence. But as we move deeper into the gallery of the Earth, the rigid 90-degree angles begin to soften and shift. The Earth's creative energy is preparing to introduce a different kind of beauty, one that moves away from the rectangle and toward the elegant, six-sided symmetry of the hexagon. From the stability of the brick, we move toward the grace of the pillar. The rigid 90-degree angles of the previous systems now begin to soften, yielding to a more graceful and rhythmic geometry. Imagine, if you will, the elegant shape of a six-sided pillar rising from the quiet dark of the Earth. This is the hallmark of the hexagonal system, a structure defined by its effortless balance and sophisticated symmetry. Unlike the boxy shapes of the cubic or orthorhombic systems, hexagonal crystals are built upon four axes of symmetry. Three of these axes lie on a horizontal plane, intersecting one another at perfect 60-degree angles, while a fourth vertical axis stands tall and perpendicular to the others. It is the same underlying geometry that gives a snowflake its delicate, six-pointed beauty, yet here in the mineral world, it manifests in stones of incredible strength and clarity. Within this six-sided family, we find some of the most cherished treasures of the Earth, the beryl family. This group includes the lush forest green emerald and the serene ocean blue aquamarine. When you see an emerald in its natural uncut state, it often appears as a perfect six-sided column, as if it were a tiny green skyscraper designed by nature itself. These crystals grow with a steady upward momentum, their hexagonal faces catching the light with a soft, glassy luster. There is a profound sense of order in these pillars, a quiet architecture that has remained unchanged for millions of years. Closely related to the hexagonal system is a subset known as the trigonal system. While it shares many similarities with its six-sided cousin, the trigonal system often expresses itself through three-sided symmetry, or a shape known as a rhombohedron, which looks a bit like a cube that has been gently pushed to one side. This is the structural home of quartz, which is the most common mineral found in the Earth's continental crust. Almost everywhere you go, quartz is there, though its crystals are often too small to see with the naked eye. In its larger crystalline forms, quartz grows in beautiful, pointed prisms. Because of its trigonal structure, a quartz crystal usually has 6 sides, but the faces at the tip are often unequal, creating a unique, staggered point that distinguishes it from the perfect symmetry of the beryl family. In this same family of three-sided grace, we find the mesmerizing tourmaline. Tourmaline is a master of color, but its shape is equally fascinating. It grows in long, slender prisms that, when viewed from the end, look like triangles with softly rounded edges. These crystals can grow quite large, stretching upward like colorful reeds in a still pond. The internal arrangement of a tourmaline crystal is so precise and complex that it allows the stone to display different colors along its length, yet it never loses that fundamental trigonal rhythm. As you lie there, feeling the gentle pull of sleep, imagine these pillars and prisms surrounding you like a silent, crystalline forest. They are tall, slender, and perfectly balanced, reaching toward the surface while remaining rooted in the deep, cool earth. The geometry of the world is becoming more intricate now, moving away from simple squares and pillars toward forms that lean and tilt in unexpected ways. We are beginning to leave the world of perfect symmetry behind, entering a space where the atoms find their places in more complex, slanted arrangements, creating a beauty that is as subtle as a whisper in the dark. As we travel deeper into the quiet geometry of the earth, the shapes we encounter begin to lose their perfect upright posture. There is a certain beauty in imperfection, or rather, in a symmetry that is more complex and subtle than a simple square or a perfect pillar. We enter the world of the monoclinic and triclinic systems, the systems of the lean and the tilt. In the monoclinic system, the internal structure of the crystal is like a rectangular box that has been gently pushed from the side so that it rests at a slight angle. It has 3 axes of unequal length, and while 2 of them meet at 90 degrees, the third intersects at an oblique angle. This creates a shape that seems to be leaning into the shadows, a form that is stable but possesses a sense of movement. One of the most famous minerals to follow this tilted path is jadeite. Jadeite is the rarest and most precious form of jade, a stone that has been cherished for thousands of years for its incredible toughness and its smooth, waxy luster. Because of its monoclinic structure, the tiny crystals within the stone are tightly interlocked, making it one of the most durable materials in the natural world. When you hold a piece of jade, it often feels cooler than other stones, a heavy and soothing presence in the palm of your hand. Another monoclinic beauty is kunzite, a gemstone known for its delicate shades of pink and lilac. Kunzite is a stone of soft light, and its tilted geometry allows it to display a phenomenon called pleochroism. Because the crystal lattice is angled just so, The stone can appear a deep violet from one direction and a pale, almost clear pink from another. It is as if the stone is hiding different layers of itself, revealing them only as you slowly turn it in the light. Further still into the world of complexity, we find the triclinic system. This is the least symmetrical of all the crystal systems. In a triclinic crystal, all three axes are of different lengths, and not a single one of them meets at a 90-degree angle. It is a world of total tilt where every face and every corner is inclined. You might imagine it as a house of cards that has begun to shift, frozen in a moment of elegant, lopsided grace. Despite this lack of traditional symmetry, the triclinic system produces some of the most visually stunning minerals on our planet. Turquoise, the ancient blue-green stone of the desert, is triclinic. Its color is as vast as a summer sky formed in arid places where water seeps through copper-rich rocks, leaving behind these complex, tilted structures. Then there is labradorite, a stone that seems to hold the northern lights within its dark, gray depths. Labradorite is a triclinic mineral, and its magical play of color is a direct result of its internal geometry. Light enters the stone and bounces off the tilted, microscopic layers of the crystal lattice, interfering with itself to create flashes of electric blue, gold, and green. It is a reminder that even in the most asymmetrical and complex structures, there is a hidden, luminous order. Take a moment now to simply breathe. Cool. Feel the weight of your body as it rests, much like these stones rest within the deep, cool layers of the earth. Imagine the darkness surrounding you, not a heavy or frightening darkness, but a protective, silent velvet. Above you are miles of stone, and within that stone, these leaning, tilting crystals are growing in total stillness. They do not need the sun to be beautiful. They simply exist, perfect in their complexity, waiting in the quiet dark. Focus on that stillness. Let your breath become slow and rhythmic, like the steady, invisible pulse of the planet itself. The earth is vast, and it is holding you safely as we prepare to descend even further into the very heart of the mantle, where the most famous of all crystals begins its long journey to the light. As we descend even further, we leave the complex, many-colored minerals of the crust behind to focus on a stone that is as simple as it is extraordinary. Consider the element carbon. It is one of the most common and essential building blocks of our world. It is in the trees, the soil, and even within our own bodies. Yet, in the deep, silent reaches of the Earth's mantle, carbon undergoes a transformation that sets it apart from all other minerals. While most gemstones are made of a complex recipe of different elements, the diamond is unique. It is the only gemstone made of just one single element, pure carbon. It is the ultimate expression of simplicity, refined by the most extreme conditions our planet can offer. To create such a stone, the earth must apply a pressure that is difficult for the human mind to grasp. Diamonds are born nearly 100 miles beneath our feet in a realm where the pressure is more than 50,000 times greater than the pressure of the atmosphere at sea level. In this deep, dark environment, the carbon atoms are squeezed so tightly that they have no choice but to bond together in the most efficient and sturdy way possible. It is a slow, quiet process of endurance, where the weight of the world above acts as a master sculptor, pressing the chaotic atoms into a perfect crystalline order. Take a slow breath and imagine that weight, not as something heavy, but as a steady, stabilizing force that brings order to the world deep below. Once formed, these diamonds remain hidden in the mantle for millions, sometimes billions of years. They are far beyond the reach of any human tool. They only reach the surface through rare and powerful volcanic events called kimberlite eruptions. These are not typical volcanic eruptions. They are deep source events that originate far below the Earth's crust. They create narrow, pipe-like structures that act as high-speed elevators, dragging the diamonds from the depths and carrying them toward the surface through the cold, solid rock. The journey is incredibly swift. Scientists believe that these kimberlite eruptions can travel faster than the speed of sound as they race toward the surface. This incredible speed is actually what saves the diamond and preserves its beauty. You see, as the pressure drops during the ascent, the carbon atoms naturally want to drift apart and return to a more relaxed state. If the journey were slow, the diamond would lose its structure and turn into graphite, the soft gray material we use for pencil lead. But because the eruption is so fast, the carbon atoms are trapped in their diamond form before they have a chance to change. The brilliance we see in a diamond is a direct result of that frantic, high-speed escape from the deep earth, frozen in time for us to see. Imagine the diamond now, after its long journey, resting in the cooling rock. It is a survivor of the most intense heat and pressure imaginable. It has been forged in a way that makes it nearly eternal, a tiny piece of the deep mantle brought into our world. As you lie there, feel the stillness around you, much like the stillness that follows the cooling of the earth. The diamond is now cool, hard, and silent. It possesses a durability that is legendary, a strength that we are only just beginning to understand. Its story is one of resilience, of a common element becoming something of peerless strength, held together by the most powerful bonds in nature. In the quiet of the night, we can appreciate the incredible journey of these stones and the unbreakable internal structure that makes them the hardest substance on our planet. Now that the diamond has reached the surface, we can begin to look closer at why it is so remarkably strong. Its endurance isn't just a result of the journey it took. It is a direct consequence of how it is built from the inside out, atom by atom. Inside a diamond, there is a perfect, unbreakable geometry that allows it to withstand the tests of time and pressure. If you could shrink down and peer into the heart of the stone, you would see a masterpiece of structural engineering. Every single carbon atom is bonded to 4 other carbon atoms, surrounding itself in a 3-dimensional shape known as a tetrahedron. These connections are not loose or flexible. They are what scientists call covalent bonds, which are the strongest type of bonds that can exist in the world of chemistry. In a diamond, these atoms share electrons so tightly that they become essentially one single continuous unit. It is as if every part of the diamond is holding onto its neighbors with an unbreakable grip, refusing to let go no matter what forces are applied from the outside. This internal lattice is so rigid and so stable that it creates a substance of peerless integrity. Because of this specific arrangement, diamonds hold the undisputed title of the hardest known natural substance on our planet. In the study of minerals, we often use a tool called the Mohs scale to measure how well a material can resist being scratched. On this scale, which ranges from 1 to 10, the diamond sits at the very top. However, the scale doesn't quite capture the true gap between the diamond and everything else. To give you a sense of its incredible toughness, a diamond is roughly 58 times harder than the next hardest mineral, which is corundum, the mineral family that gives us rubies and sapphires. While a sapphire is remarkably durable, it simply cannot compare to the absolute structural perfection of the diamond's carbon lattice. This extreme hardness leads to a very quiet, poetic reality. Nothing in the natural world can leave a mark on a diamond except for another diamond. To shape these stones into the brilliant, multifaceted gems we recognize, master cutters must use tools tipped with diamond or coated in diamond dust. It essentially takes the strength of the stone itself to reveal its own inner light. This sense of permanence, of an internal order that cannot be broken by anything else in nature, gives the diamond a unique place in our world, a tiny frozen piece of the deep earth that remains unchanged for eons. But while the diamond represents the extreme end of geological rarity and strength, the Earth's crust is also home to other wonders that are far more common, yet just as captivating in their own gentle way. As we move away from the deep, high-pressure environment of the mantle and look toward the layers of the Earth closer to the surface, we encounter a mineral that is as versatile as it is beautiful. This is the expansive world of quartz. Unlike the diamond, which is forged in the hidden depths, quartz thrives in the light and the cool of the upper crust, appearing in an almost infinite variety of colors and shapes, waiting to be discovered in the sand, the soil, and the mountains. If the diamond is the rare hidden treasure of the deep, quartz is the gentle, ubiquitous spirit of the Earth's surface. It is a mineral that seems to be everywhere at once, hidden in plain sight. Yet it never loses its capacity to surprise us with its quiet, unassuming beauty. If you were to look at the world through a geologist's eyes, you would see that quartz is a masterpiece of simplicity, built from the two most common elements found in the Earth's crust, silicon and oxygen. In its most basic scientific form, it is known as silicon dioxide, a structure composed of just 1 part silicon and 2 parts oxygen. These elements come together in a slow, geometric dance, creating a mineral that is as sturdy as it is elegant. Because its building blocks are so plentiful, quartz has become the second most abundant mineral in all of the Earth's continental crust. It is, quite literally, the very fabric of our world. When you walk along a soft, white beach and feel the sand between your toes, you're most likely feeling millions of tiny grains of quartz that have been tumbled and smoothed by the rhythmic pulse of the ocean for thousands of years. When you look at a towering mountain range, quartz is often the shimmering vein running through the dark granite, holding the landscape together with its resilience. It is a constant, steady presence in the background of our lives, a silent witness to the changing of the seasons and the slow passing of the ages. In its purest, most untouched state, quartz is completely colorless. and as transparent as a clear window pane. This variety is often called rock crystal, and it possesses a clarity that can be truly breathtaking. If you were to hold a piece of high-quality rock crystal in your hand, it would feel cool and heavy, looking so much like a shard of frozen water that you might almost expect it to melt against the warmth of your palm. This striking resemblance to ice was not lost on the people of the ancient world. The ancient Greeks looked at these clear, cold stones and believed they were looking at ice that had been frozen so deeply and for so long by the gods that it had lost the ability to ever turn back into water. They called it crystallos, a word that literally meant ice. And it is from this ancient belief that our modern word crystal was born. There is something deeply peaceful about that image, the idea of a stone that carries the stillness and the purity of a frozen mountain stream, locked forever in a solid, unmoving form. But quartz is more than just a beautiful object to behold. It also possesses a hidden, almost magical energy that connects the natural world to our modern lives. Quartz is what scientists call piezoelectric. This means that if you apply physical pressure to a quartz crystal, if you squeeze it or bend it even slightly, it generates a tiny measurable pulse of electricity. This remarkable property allows quartz to act like a tiny, steady heartbeat within our technology. It is what keeps our watches ticking with perfect precision and allows our electronics to maintain a steady rhythm. Even as it rests silently in the earth, quartz is alive with a subtle, rhythmic energy, a reminder of the complex forces that hum beneath the surface of our quiet world. While the pure, clear beauty of rock crystal is a wonder in itself, quartz rarely remains so simple. As it grows within the dark cracks and cool crevices of the Earth's crust, it often encounters other elements, tiny travelers that find their way into the crystal lattice as it forms. These small additions, though they may seem insignificant, are the secrets behind the breathtaking rainbow of colors that quartz can display. Just as a single drop of ink can transform a glass of water, these trace minerals and natural forces can turn a clear stone into something vibrant and mysterious, leading us away from the transparent world of ice and into a world of deep royal purples, warm, sun-drenched golds, and soft, dusty pinks. Imagine a geode, a rough and unassuming rock on the outside, looking like nothing more than a common stone you might find on a dusty path. But when it is carefully cracked open, it reveals a hidden kingdom of deep royal purple. This is amethyst, perhaps the most beloved variety of quartz in the world. Its color is a masterpiece of chemistry and time. As the quartz grew, tiny amounts of iron were trapped within its structure. Over millions of years, natural radiation from the surrounding rocks acted upon that iron, changing its state and creating what scientists call color centers. This process, known as irradiation, is what gives amethyst its regal hue, ranging from a pale, delicate lilac to a purple so dark and velvety it looks like the sky just after the sun is set. If that same amethyst is buried deep enough for the Earth's natural internal warmth to bake it, a remarkable transformation occurs. The heat alters the state of the iron once again, and the purple fades, turning instead into a vibrant, sun-drenched yellow or a warm, honey-colored gold. This variety is known as citrine. In the wild, natural citrine is quite rare, a gift from the Earth's own subterranean oven. It carries a brightness that feels like a trapped ray of sunshine, a warm glow that persists even in the darkest reaches of a mountain. In other parts of the crust, where the surrounding granite contains higher levels of natural radioactive elements, quartz takes on a different, more mysterious personality. It becomes smoky quartz. Instead of being clear or brightly colored, it turns a translucent gray or a deep tea-like brown, sometimes appearing almost black. It looks as though a wisp of dark smoke has been captured and held still within the stone. Despite its moody appearance, smoky quartz is often incredibly clear, allowing light to pass through its shadows with a soft, muted elegance that feels grounded and peaceful. Then there is rose quartz, with its soft, hazy pink that looks like the first light of a quiet dawn. Unlike the sharp, clear points of amethyst or smoky quartz, rose quartz is often found in large, translucent masses. Its gentle color comes from trace amounts of titanium, iron, or manganese. It often has a slightly milky or cloudy appearance, which gives it a old, ethereal quality, as if it is glowing from within a dream. Sometimes quartz chooses not to grow into the large, recognizable points we see in museums. Instead, it forms a structure so fine and dense that the individual crystals are too small to be seen, even under a standard microscope. This is known as cryptocrystalline quartz, or chalcedony. Because the crystals are so tiny and tightly packed, chalcedony feels smooth and waxy to the touch. It is the family that gives us the banded beauty of agate, the deep oranges of carnelian, and the earthy greens of jasper. It is a reminder that even when the structure is hidden from our eyes, the order and the beauty of the mineral remain perfectly intact. As we move through these various forms of quartz, we begin to see how versatile and resilient this mineral truly is. It is everywhere, yet it never ceases to surprise us with its many faces. But as we continue our journey deeper into the Earth's treasury, we leave the world of silicon and oxygen behind and move toward a mineral family that is even tougher and more brilliant. We are moving toward a substance that, in its purest form, is as clear as the air, but when touched by the right elements, produces the most legendary colors in the history of gemstones. As we descend further into the quiet layers of the earth, we leave the familiar world of quartz behind. We are entering a realm of even greater strength and brilliance. Imagine a mineral that is so hard, so resilient, that it is surpassed only by the diamond itself. This is the world of aluminum oxide, a mineral known to geologists and gemologists as corundum. In the stillness of the deep crust, corundum forms under immense heat and pressure, growing slowly into crystals that possess a remarkable durability. On the Mohs scale, which scientists use to measure how minerals resist being scratched, corundum holds a prestigious and formidable position at number 9. To put this into perspective, it is significantly harder than quartz and nearly every other common mineral. This extreme hardness means it is an incredibly sturdy traveler through time. While other stones might wear down, become rounded by ancient rivers, or lose their sharp edges over millions of years, corundum remains crisp and clear. It is a symbol of endurance, a quiet survivor in the shifting, churning depths of the Earth's mantle and crust. When you imagine a piece of corundum, you are imagining something that has withstood the weight of mountains without flinching. In its most perfect untouched state, corundum is completely colorless. It is as clear as a drop of pure mountain water, allowing light to pass through it without any change at all. These rare colorless stones are sometimes called white sapphires, but it is very uncommon to find in such absolute purity in the wild. The Earth is a diverse place, and more often than not, it adds its own secret ingredients to the mineral mix. It is these tiny impurities, microscopic amounts of other elements, that turn this simple aluminum oxide into the legendary treasures we know today. When a small amount of the element chromium finds its way into the crystal lattice as it grows, something extraordinary happens. The clear, transparent stone is transformed into a vibrant, pulsing red. This, and only this, is what we call a ruby. For thousands of years, the ruby has been cherished above almost all other stones, often referred to as the king of gems. It possesses a warmth and a concentrated vitality that seems to glow with its own internal fire. Even in the dimmest light, if the trace elements within the corundum are anything other than chromium, the stone is classified as a sapphire. While many of us immediately think of a deep midnight blue when we hear the word sapphire, they actually exist in a breathtaking rainbow of colors. There are yellow sapphires that look like drops of liquid honey, green sapphires that mimic the shade of a forest canopy, and even rare, sought-after orange-pink sapphires that resemble the soft light of a tropical sunset. The classic blue sapphire, the one that reminds us of the deepest parts of the ocean or the sky, just after the sun has dipped below the horizon, gets its color from a delicate chemical dance between iron and titanium. These two elements work together to absorb certain wavelengths of light, leaving behind only that rich, velvety blue that has captivated the human imagination for millennia. But of all the colors in the corundum family, there is one that carries a weight of history and mystery unlike any other. It is a specific, intense shade of red, often described by the traditional name pigeon blood red. This color is the hallmark of the most precious rubies in the world. It is a hue so deep and saturated that it seems to hold a life of its own, a silent testament to the incredible forces required to create it. As we settle into the stillness of this subterranean world, we begin to look closer at the ruby, exploring the rare and difficult journey it must take to reach such a perfect, glowing state. Imagine for a moment the incredible precision required for the Earth to create a single ruby. It is not merely a matter of heat and pressure, it is a delicate balancing act of chemistry that happens only in a few rare pockets of the world. For a ruby to emerge, the environment must be almost entirely free of silica, which is one of the most common elements in the Earth's crust. If there is too much silica present, the ingredients will form other more common minerals. But in certain places, often within beds of white marble, the Earth manages to keep the silica away, allowing the aluminum and oxygen to bond into the hard, resilient structure of corundum. Into this pure structure, the Earth introduces a guest, the element chromium. Chromium is a remarkable substance. It is the very thing that grants the ruby its signature red, but it does something even more magical that you might not notice at first glance. Chromium causes the ruby to fluoresce. This means that when the stone is touched by ultraviolet light, the kind of light found in natural sunshine, the atoms of chromium absorb that energy and then release it as visible red light. This internal reaction gives the ruby a quality that no other stone truly possesses. In the light of day, a fine ruby does not just reflect the sun. It seems to glow from within, as if it holds a tiny eternal flame that refuses to be extinguished. It is a pulse of light that feels alive, a secret radiance born of chemistry and darkness. But this beauty comes with a biological cost to the crystal itself. Chromium is a relatively large atom, and as it tries to fit into the tight, orderly lattice of the corundum, it creates a great deal of internal stress. This tension acts as a natural limit on how large a ruby can grow, while other crystals like quartz or even some sapphires can grow to be quite massive. Rubies are almost always found in small, modest sizes. It is as if the intensity of their color is too much for the stone to hold in large quantities. This is why a ruby that is larger than just a few carats and possesses a clear, deep red color is such a profound rarity. Most of these treasures are found in marble that has been subjected to intense heat and pressure over millions of years. This marble provides the perfect low silica sanctuary for the ruby to slowly take shape. Because the conditions for their birth are so specific and so rarely met, a high-quality ruby is often significantly more valuable than a diamond of the same size. While diamonds are famous for their brilliance, a perfect ruby represents a unique triumph of nature over the odds, a rare alignment of the Earth's most hidden elements. As we linger on the image of that warm, glowing red, we can feel the temperature of our thoughts begin to cool. We leave behind the fiery intensity of the corundum family and prepare to move toward a different kind of beauty. We are traveling now from the deep, pulsing reds of the Earth's heart toward the tranquil, refreshing greens of a different mineral family. We are moving toward the world of beryl, a family of stones that look less like fire and more like the quiet, sun-dappled shadows of an ancient forest. Take a slow, deep breath as we transition from the warmth of the ruby to the serene, cooling depths of the emerald. Let the warmth of the ruby fade away now, replaced by a cool, refreshing stillness. We are entering the world of the beryl family, a group of minerals that embody the tranquility of a deep, quiet forest. At the heart of this family is the emerald, perhaps the most beloved green gemstone in history. To understand the emerald, we must first look at its foundation. In the quiet language of geology, beryl is a mineral composed of beryllium aluminum cyclosilicate. It is a complex name for a very orderly structure where rings of atoms stack upon one another to create long hexagonal prisms. In its purest form, beryl is as clear as a drop of rainwater, but nature rarely leaves a canvas empty. When tiny amounts of chromium or vanadium find their way into the beryl's lattice as it grows, the stone undergoes a transformation. It begins to glow with a rich, verdant green. This is the emerald. It is a color that feels ancient and soothing, like the moss on a stone or the leaves of a willow tree hanging over a still pond. Take a moment to imagine that color, a green so deep it feels like you could fall into it and be perfectly safe. As you visualize this green, imagine looking closer into the very heart of the stone. Unlike many other gemstones that strive for perfect empty clarity, emeralds hold a secret world within them. Almost every natural emerald contains tiny internal fractures and mineral inclusions. Gemologists have a beautiful name for these internal features. They call them jardins, the French word for gardens. When you peer into an emerald, you are looking at a miniature landscape of mossy veils, tiny crystals, and delicate branches of trapped gas or liquid. These are not flaws in the traditional sense. They are the fingerprints of the earth. In fact, these jardins are so characteristic of the emerald that they are used by experts to prove the stone is a natural creation of the planet. A stone without these tiny internal gardens is often a sign of something man-made, lacking the chaotic, beautiful history of a mountain-born gem. They are the evidence of the immense pressure and the slow, difficult growth the stone endured miles beneath the surface. There is a gentle paradox in the emerald's nature. While it is a very hard stone, ranking high on the scales of mineral durability, it is also surprisingly brittle. Those same internal gardens that give it such character also make it sensitive. An emerald cannot withstand the same rough treatment as a diamond or a ruby. It must be handled with a certain softness, a quiet respect for its delicate structure. It is a reminder that strength and fragility can exist in the same space, held together by the weight of time. But the beryl family is wide and varied, and the emerald is only one of its many expressions. The same chemical structure that creates these deep greens can also produce colors of startling clarity and different moods. As we move away from the deep shaded greens of the forest, we find ourselves approaching the edge of a vast sunlit ocean. The same mineral structure can take on the colors of the sea, the sky, and even the softest pinks of a morning sunrise. Let your mind drift now as we leave the gardens behind and move toward the serene, watery blues of the emerald's closest cousins. Imagine standing on the edge of a calm tropical sea, where the water is a pale, translucent blue that stretches toward the horizon. This is the color of the aquamarine, the serene sibling of the emerald. While the emerald is a deep shadowed green, the aquamarine is the blue to green-blue variety of the beryl mineral family. It is a stone that feels light, airy, and incredibly peaceful, like a cool breeze on a still afternoon. The secret to this watery hue lies in the presence of iron. While chromium gave the emerald its intense green, a few stray atoms of iron within the beryl crystal lattice transform it into an aquamarine. Depending on the amount and type of iron present, the stone can range from a very pale, almost ghostly blue to a rich, deep teal. It is a color that captures the essence of a summer sky or the clarity of a mountain spring, frozen in time and stone. One of the most remarkable things about aquamarine is its clarity. You may remember that emeralds are almost always filled with jardines, those tiny internal gardens of fractures and inclusions. Aquamarines, however, are quite different. They often grow in very large, exceptionally clear crystals. It is not uncommon to find an aquamarine that is completely transparent, with no visible flaws at all, even when the crystal is quite massive, because they grow so large and so pure. They have been admired for centuries as symbols of honesty and tranquility. They are like windows of frozen seawater, allowing light to pass through them without any interruption. But the beryl family has more colors to share with us in the quiet of the earth. If we replace that iron with tiny amounts of manganese, the stone takes on a completely different personality. It becomes a soft, delicate pink or peach color known as morganite. Morganite is a stone that feels like a warm embrace or the first light of a quiet dawn. It is a gentle, blush-colored gem that reminds us of the subtlety of nature's palette, showing that even the hardest rocks can possess a tender, soft beauty. And then there is the golden yellow variety of beryl, known as heliodor. Its name comes from the Greek words for sun and gift, and looking at one, you can see why. Heliodor is like a piece of captured sunshine, glowing with a bright, cheerful yellow or a deep, honey-like gold. It is a vibrant contrast to the cool blues of the aquamarine and the soft pinks of the morganite. Yet they all share the same hexagonal crystal structure, the same fundamental geometry. Take a slow, deep breath now. As you listen, try to imagine these different colors of beryl, the sea blue, the soft pink, and the golden yellow, all resting in the dark, cool layers of the Earth's crust. They are tucked away in pockets of rock, protected by mills of solid stone above them. Feel the weight of that earth, not as a heavy burden, but as a warm, protective blanket that keeps the world's treasures safe and still. Everything is quiet. Everything is as it should be. The earth is vast, and you are safe within its gentle ancient rhythm. Allow yourself to sink a little deeper into your bed as we prepare to move from these clear, watery stones to a family of gems that comes in almost every color imaginable. Leaving the clear, hexagonal prisms of the beryl family behind, we move into a world of even greater variety and ancient history. Imagine, if you will, the garnet. While many people think of a garnet as a single type of stone, it is actually a diverse and colorful family of minerals. They are not just one thing, but a group of closely related minerals that share a similar crystal structure, yet each has its own unique chemical recipe. This variety allows the garnet to appear in a stunning array of colors, like a hidden rainbow tucked away in the shadows of the Earth's crust. In the quiet darkness where these stones grow, they form in almost every color you can imagine. There are garnets that glow with the warm orange of a flickering candle, and others that shine with the bright yellow of a summer meadow. You might find them in deep violets or soft pinks. It is a curious fact of nature that while garnets embrace nearly every hue, a true deep blue is incredibly rare, almost a myth in the mineral world. This absence only makes the other colors seem more vivid, more intentional. Take a slow, quiet breath and imagine this spectrum of color resting in the cool, dark earth, waiting in total stillness. The most common member of this family, the one that most people recognize, is called almandine. It is a stone of deep, dark reds, the color of a pomegranate seed or a heavy velvet curtain. In the low light of a bedroom, an almandine garnet looks almost black, but when a soft light catches it, the deep crimson glow emerges from within. It is a sturdy, reliable stone, one that has been part of the Earth's story for millions of years, forming deep within metamorphic rocks as they are squeezed and heated by the movements of the crust. But the garnet family also holds surprises. High in the mountains and deep in the valleys of East Africa, a rare and vibrant green garnet can be found, known as savorite. Unlike the deep red of the almandine, the savorite is a bright electric green like the color of fresh grass after a spring rain. It is a relatively recent discovery in the long history of gemstones. Yet its beauty is so intense that it is often compared to the finest emeralds. It reminds us that the earth still holds secrets, even in families of stones we think we know well. Humans have felt a connection to these stones for a very long time. Garnets have been used as gemstones since the Bronze Age, thousands of years before our modern world began. Ancient civilizations carved them into beads and set them into gold, believing they were symbols of strength and protection. There is a beautiful old legend that Noah used a finely carved, glowing garnet to illuminate the ark during the dark, stormy nights of the Great Flood. Whether or not that is true, it captures the feeling of the stone, a steady, warm light in the darkness. As you lie there, feeling the stillness of the room around you, think of these ancient garnets resting in the soil and the rock, having been there for thousands upon thousands of years. They are patient. They are still. They do not hurry, and neither do you. Everything is calm. Everything is quiet. We are now moving from the sturdy ancient world of the garnet to a stone that is even more mysterious. This next tune is known as the gemstone of 1,000 colors, a mineral so complex that it seems to capture the very essence of light and energy. It is a stone that can even carry a quiet electric charge, reacting to the warmth of the world around it. Let us turn our attention now to the remarkable and electric world of the tourmaline. Imagine a stone that contains within it every color of the rainbow. This is tourmaline, a mineral often called the gemstone of 1,000 colors. For centuries, it was frequently mistaken for other gems, rubies, emeralds, or sapphires, simply because it can mimic their hues so perfectly. But tourmaline is a master of disguise, a complex and beautiful creation that stands entirely on its own. One of the reasons for its incredible variety is its chemical makeup. Tourmaline has one of the most complex chemical formulas of any mineral found in the Earth's crust. It is not just a single mineral, but a group of related minerals that share a common structure, but have slightly different ingredients. Scientists often describe it as a complex silicate of boron and aluminum, but nature adds many other elements to the mix, such as iron, magnesium, lithium, and even potassium. Depending on which of these elements are present, the stone might turn a deep forest green, a vibrant pink, or a midnight blue. It is as if the earth, in a moment of creative abundance, decided to put a little bit of everything into this one stone. There is a strange and hidden energy inside tourmaline that sets it apart from almost every other gemstone. It is what we call pyroelectric. This means that if you gently warm a tourmaline crystal, it becomes electrically charged. One end of the stone becomes positive and the other becomes negative. much like a tiny natural battery. In the quiet of the earth, as the temperature shifts ever so slightly, the stone carries this silent, invisible charge. In the 1700s, Dutch traders who traveled across the oceans discovered this curious property. They noticed that when their tourmaline crystals became warm, they would begin to attract dust and light pieces of ash. They gave the stone a charming nickname, Trekker, or ash puller. They would use the warm stones to pull the stray ashes out of their long tobacco pipes. It is a peaceful image. Traders sitting in the warmth of a cabin, watching as a beautiful, colorful stone quietly cleans their pipes with nothing more than the energy of heat. Sometimes nature creates tourmaline in patterns that seem almost too perfect to be real. One of the most beloved varieties is the watermelon tourmaline. In these crystals, the center of the stone is a soft sunset pink, while the outer rim is a cool, refreshing green. When a crystal is sliced into a thin disc, it looks exactly like a tiny mineral version of a slice of watermelon. It is a reminder of the playfulness of the natural world, a small piece of art grown in the dark, silent pressure of the earth. Even rarer still is the Paraiba tourmaline, a stone that was only discovered quite recently in the hills of Brazil. This variety glows with an intense neon blue or turquoise color that seems impossible for a natural stone. This electric glow comes from trace amounts of copper trapped within the crystal lattice. When you look at a Paraiba tourmaline, it looks as though it is lit from within, like the glow of a tropical sea under a bright sun. Take a slow, deep breath and let your mind rest on these vibrant colors, the pinks, the greens, and the glowing blues. All of these stones we have discussed so far have shared a common secret. They are all crystals. They are all built with a rigid geometric order where every atom has its perfect assigned place. But as we move deeper into the treasures of the earth, we find a stone that breaks all those rules. It is a stone that is not a crystal at all, but something more fluid, more mysterious, filled with the essence of water. Let us leave the structured world of crystals behind and enter the soft, shifting light of the opal. As we shift our focus from the rigid, unyielding patterns of diamonds and tourmalines, we enter a world that is much softer, more mysterious, and almost fluid in its nature. This is the world of the opal. While every stone we have explored so far is defined by its crystalline structure, that perfect repeating geometry of atoms, the opal is different. It is what scientists call amorphous. This word simply means without form. In the deep, quiet places of the earth, the opal did not grow into a strict, repeating lattice. Instead, it began its life as a silica-rich gel that slowly hardened over immense periods of time, retaining a sense of movement and mystery within its very heart. Because it lacks that fixed internal arrangement, it does not form the sharp, predictable faces of a crystal. It is a stone that feels more organic, more patient, as if it is still remembering the liquid state from which it came. If you were to look deep inside an opal with a powerful microscope, you would not see the sharp angles of a cube or the six-sided symmetry of a barrel. Instead, you would see millions upon millions of tiny microscopic spheres. These are spheres of silica stacked together in a way that resembles a collection of tiny marbles or a honeycomb. It is this unique non-crystalline arrangement that gives the opal its soft, ethereal character. Because it lacks a true crystal structure, the opal is not classified as a mineral in the strictest sense. Instead, geologists call it a mineraloid. It is a beautiful, natural substance that shares many qualities with minerals, but follows its own, more flexible rules. It belongs to the same family as amber and volcanic glass, treasures of the earth that chose a different path than the structured world of crystals. Perhaps the most fascinating secret of the opal is that it is a stone born of water. Within its structure, trapped forever between those millions of tiny silica spheres, is actual moisture. Most precious opals contain between 3% and 21% water. It is a strange and lovely thought that a stone found deep within the heavy, dry earth could hold a hidden reservoir of ancient water. This water is what gives the opal its weight and its signature coolness to the touch. It is a gemstone that feels almost like a living thing, a piece of the earth's memory of rain and ancient seas, frozen in time and protected by the stone around it. The journey of an opal often begins in some of the driest, most silent places on our planet. Most of the world's precious opal is found in the vast red deserts of Australia, in places with names that sound like poetry, such as Coober Pedy and Lightning Ridge. Millions of years ago, these arid plains were covered by a shallow inland sea. As the waters receded and the land began to dry, silica-rich water seeped deep into the cracks and cavities of the earth, filling the spaces left behind by decaying wood, ancient shells, and even the bones of dinosaurs. In the absolute silence of the underground, as the desert sun beat down on the surface far above, this water slowly evaporated over millions of years. What remained was the silica gel that would eventually harden into the opals we treasure today. Take a slow, quiet breath and settle deeper into your bed, feeling the stillness of the air around you. Imagine those vast, quiet deserts at night, where the only sound is the soft whisper of the wind over the sand, and the stars seem close enough to touch. Deep beneath that sand, protected by layers of ancient rock, the opals rest in the darkness. They are waiting, holding their hidden water and their silent, microscopic spheres. And it is within this unique watery structure that a miracle of light begins to take place. As light enters the opal and winds its way through those millions of tiny stacked spheres, it begins a dance that no other stone can replicate, creating colors that seem to shift and change with every movement. Imagine a single ray of light finding its way into the heart of an opal. It doesn't just pass through, it enters a microscopic world of perfectly stacked spheres, a hidden architecture of light and shadow. This is what scientists call the play of color. It isn't a pigment or a dye, but a physical dance of light. When the light hits those gaps between the silica spheres, it breaks apart and bends in a process known as diffraction. Think of it as a soft, silent melody played by the light as it bounces through a microscopic maze, creating a shimmering effect that seems to move as you turn the stone in your hand. The colors you see depend entirely on the size of those tiny spheres. It is a beautiful bit of geometry occurring on a scale too small for the human eye to see. When the spheres are relatively large, they have the space to bend the light into warm, glowing reds and oranges, colors that feel like a dying campfire in the twilight. When the spheres are smaller, the gaps are tighter, and they produce the cool, serene flashes of blue and green like the surface of a deep, still lake or the leaves of a forest in the rain. In a single stone, you might see a whole sunset or a rolling ocean, all depending on how those tiny spheres were laid down millions of years ago in the silence of the earth. But for this magic to happen, the spheres must be arranged in a perfect, orderly grid, like rows of seeds in a garden or bricks in a wall. If the spheres are scattered randomly, without any pattern, the light becomes lost and muffled. This is what we call common opal. It is still beautiful, with a soft, milky, translucent glow, but it lacks that shimmering dance of color. It is a stone at rest, quiet and humble, waiting for the light to pass through without making a sound. Among all the varieties, the black opal is perhaps the most mesmerizing to behold as you drift toward sleep. Its name is a bit of a mystery, as the stone itself isn't truly black. Instead, it has a dark body color, deep grays, charcoals, or midnight blues, that acts like a velvet curtain. This dark background provides a stark contrast, allowing the vibrant flashes of red, gold, and violet to pop with an intensity that seems almost impossible. It is like watching fireworks against a midnight sky, a silent, frozen celebration of color, held within a cold, heavy stone. Because the opal is born of water, it remains a delicate and sensitive treasure. It is one of the few gemstones that can be affected by the air around it, almost as if it is still part of the living world. If an opal is kept in a place that is very dry for many years, the tiny bit of ancient water trapped inside can begin to evaporate. When this happens, the stone may lose its luster or develop tiny, fine cracks on its surface, a process jewelers call crazing. It is as if the stone is breathing, needing a little bit of humidity to stay whole and vibrant. It is a gentle reminder that even something as ancient as a rock can have a relationship with the atmosphere, requiring care and a soft touch to remain beautiful. As you lie there, feeling the weight of your blankets and the steady, calming rhythm of your breath, think about how light travels. It doesn't just show us the world. It interacts with it in ways that are both complex and incredibly peaceful. It slows down, it bends, and it changes its nature, depending on what it touches. The opal is just one example of how the earth uses the simple laws of physics to create art in the darkness. But the way light moves through a stone is a science all its own, a study of speed, angles, and the hidden paths that light takes when it leaves the air and enters a world of solid, crystalline beauty. Each stone has its own way of greeting the light, bending it to its will, and showing us colors we might never have imagined. Imagine a beam of light traveling through the quiet, still air of a room and then meeting the cool, polished surface of a gemstone. This moment is where a hidden transformation begins. The stone does not just let the light pass through it like a window. Instead, it takes hold of the light, guiding it through a complex microscopic maze of atoms. It is a slow and silent manipulation of energy that gives these minerals their inner life and their ethereal glow. As you settle deeper into your pillows, imagine that light entering a world where time slows down and the rules of the air no longer apply. When that light moves from the thin, invisible air into the dense, solid body of a crystal, it performs a graceful maneuver known as refraction. This is, quite simply, the bending of light. Just as a wooden spoon appears to bend or shift, when you rest it in a glass of water, light changes its path the moment it touches the surface of a gem. This gentle bend is the first step in the stone's ability to capture the light and pull it into its heart, creating the depth we see when we look into a well-cut jewel. It is as if the stone is reaching out and catching the light, drawing it inward to explore its interior. How much the light bends depends on a property scientists call the refractive index, or RI. You can think of this as a measure of how much the stone slows the light down. In the vast open emptiness of space, light travels at its greatest unimpeded speed. But inside the crowded, orderly structure of a mineral, it must navigate through a dense forest of atoms. Every gemstone has its own unique index, a mathematical signature of how it interacts with the world outside. Some stones allow light to pass through with only a slight delay, while others bring it almost to a crawl. Diamonds are famous for having one of the highest refractive indices of any natural substance on Earth. When light enters a diamond, it is slowed down dramatically, forced to bounce off the internal walls of the crystal like a silver ball in a hall of mirrors. This intense bending and internal reflection is what creates brilliance, that bright white light that seems to radiate from the very center of the stone. It is as if the diamond is hoarding the light, turning it over and over, reflecting it back upon itself, before finally letting it escape to find your eyes. It is a concentrated, frozen form of brightness. But sometimes the stone does more than just bend the light. It pulls it apart into its hidden components. This beautiful effect is called dispersion, though in the world of gemstones it is often known simply as fire. As white light travels through the crystal, the different colors that make it up, the deep reds, the soft oranges, the cool blues, all travel at slightly different speeds. This causes them to fan out, creating tiny vivid rainbows that flicker and dance as the stone is moved. It is a silent, cold fire, one that creates a sense of warmth and color without any heat at all, a shimmering display held within the stillness of the rock. There is another, even more mysterious way that some stones play with the light that enters them, a phenomenon known as pleochroism. In these rare minerals, the internal structure is arranged in such a way that it absorbs different wavelengths of light depending on the direction it is coming from. If you were to hold such a stone and slowly turn it in your hand, you might see it shift its identity before your eyes, moving from a soft, oceanic blue to a pale, grassy green, or from a deep royal violet to a warm, earthy brown. It is a gentle, optical secret, a reminder that what we see depends entirely on our perspective and the way the stone chooses to reveal its many faces. As we linger on these thoughts of light and color, we can begin to look closer at the specific stones that have mastered these optical tricks. Two in particular stand out for their remarkable clarity and their ability to catch the light in ways that have fascinated humans for thousands of years. One is the steady, clear topaz, and the other is the ancient, fiery zircon. Both have their own stories to tell about how they were born in the heat of the earth and how they learned to dance with the light in the darkness. Imagine, if you will, the stillness of a crystal clear mountain stream where the water is so pure and so calm that it seems almost invisible. This is the natural state of topaz in its most pristine form. As it grows in the quiet, dark cavities of the Earth's crust, topaz is completely colorless. It is a stone of incredible clarity, looking like a drop of frozen rainwater that has never known a single impurity. While many of us imagine topaz as a bright oceanic blue, that specific color is rarely found in nature. Most of the blue topaz we see has been gently helped along by human touch to reveal a hidden potential that the earth left dormant. However, there is a rare and magnificent exception to this rule, a bryony that holds the warmth of a setting sun within its very core. This is known as imperial topaz. It is a natural treasure found in only a few places on our planet, boasting hues of reddish orange, golden peach, and soft pink. To look into a piece of imperial topaz is to see the colors of a dying ember, a warm and comforting glow that has been preserved in stone for millions of years. It grows slowly, undisturbed, taking on the strength of the mountains that surround it. As we move our focus from the clarity of topaz, we encounter a stone that specializes in a different kind of magic, the zircon. Zircon is a master of the fire we spoke of earlier. Its ability to take a single beam of white light and shatter it into 1,000 tiny rainbows is nearly unparalleled. Its dispersion is so high, so intense, that it rivals even the brilliance of a diamond. When you hold a zircon in the light, it does not just shine, it flickers with a restless, colorful energy, as if it is trying to tell a story in a language made entirely of light. There is a common misunderstanding that often surrounds this beautiful mineral. Because of its name, people frequently confuse natural zircon with cubic zirconia, which is a modern man-made material. But zircon is far from a laboratory invention. It is one of the oldest minerals on our planet, a true veteran of geological history that has witnessed the rising and falling of continents. It is a natural gift from the earth, a stone that was born in the intense heat of cooling magma billions of years ago. Deep within the microscopic lattice of a zircon, there is a strange and silent secret. These crystals often contain tiny trace amounts of radioactive elements like uranium and thorium. Over the course of hundreds of millions of years, the energy released by these elements acts like a slow, rhythmic pulse within the stone. This energy gradually breaks down the crystal's own internal structure from the inside out, a process that geologists call metamictization. It is a transformation so slow that it defies human imagination, turning a once rigid crystal into a softer, glass-like state over eons of time. It is as if the stone is slowly changing its soul while it rests in the darkness. These minerals, the clear, steady topaz and the ancient, fiery zircon, show us how light can be held, bent, and transformed by the steady hands of nature. But as we continue our journey deeper into the world of gems, we find that some stones take this transformation even further. There is a stone that does not just play with light, but seems to live a double life, changing its very identity depending on the light that touches it. Let us move our thoughts now toward the rare and mysterious beauty of the alexandrite, a gem that is as elusive as it is enchanting. Imagine a stone that lives a double life, a quiet chameleon of the mineral kingdom that seems to change its very essence as the day turns to night. This is the alexandrite, often described by those who love it as an emerald by day and a ruby by night. It is a rare and captivating variety of the mineral chrysoberyl, and its ability to shift colors is one of the most enchanting sights in all of geology. When the world is bathed in the cool blue-rich light of the morning sun, an alexandrite appears as a soft mossy green or a bright vivid teal. It feels fresh and tranquil, like the leaves of a forest after a spring rain. But as the day fades and you bring the stone into the warm golden glow of a fireplace or the soft light of an incandescent lamp, something extraordinary happens. The green begins to melt away, replaced by a rich purplish red or a deep raspberry hue. In an instant, the stone that felt like a cool forest now feels like glowing ember. This remarkable trick of the light is not magic, though it certainly feels like it. It is the result of a very specific interaction between light and the element chromium. Deep within the crystal's lattice, chromium atoms are arranged in such a way that they absorb certain wavelengths of light while reflecting others. Because our eyes perceive light differently depending on the source, whether it is the balanced blue-toned light of the sun or the warm red-toned light of a flame, the alexandrite simply responds to its environment. It is a mirror to the world around it, changing its appearance to match the quality of the light that touches it. The history of this stone is as dramatic as its color change. It was first discovered in the 1830s, tucked away in the rugged, snow-dusted peaks of Russia's Ural Mountains. Legend tells us it was found on the very day that the future Tsar Alexander II came of age, and because its colors, red and green, matched the military colors of Imperial Russia, it became a symbol of national pride. For decades, the Russian mines were the only known source of this treasure, making it a gemstone of immense prestige and mystery. Even today, alexandrite remains one of the rarest and most expensive gemstones in the world. To find a crystal that is large, clear, and possesses a dramatic color change is a geological miracle. It requires a perfect alignment of elements and conditions deep within the earth. Conditions that occur so infrequently that many people will never see a natural alexandrite in person. It is a quiet reminder that the earth still holds secrets that are both beautiful and elusive, hidden away for millions of years until the right moment. As we let the shifting colors of the alexandrite fade into the back of our minds, take a slow, deep breath. Feel the stillness of the air around you, We are beginning to move away from the transparent gems that play so busily with light. We are traveling towards stones that are solid and steadfast, minerals that do not let light pass through them, but instead hold their deep, rich colors on the surface. We are entering the world of the ancient opaque stones, stones that have been carved into talismans and treasures since the very dawn of human history. Let us turn our attention now to the deep midnight blues and the desert greens of the Earth's most storied rocks, starting with the celestial beauty of lapis lazuli. Imagine a deep midnight sky, so vast and quiet that it seems to stretch on forever. This is the beauty of lapis lazuli, a stone that has been cherished by civilizations for thousands of years. Unlike many of the gemstones we have explored so far, lapis lazuli is not actually a single mineral. It is a rock, a harmonious blend of several different minerals that have grown together over millions of years. This combination gives the stone its unique, opaque texture, a solid and comforting weight that feels grounded and ancient. The striking, intense blue that defines lapis comes primarily from a mineral called lazurite. It is a color so deep and pure that for centuries, artists would grind this stone into a fine powder to create ultramarine, the most expensive and sought-after pigment in the world. But if you look closely at a piece of high-quality lapis, you will see more than just blue. You will see tiny glittering specks of gold. These are not actually gold, but inclusions of pyrite. These golden flecks look like a scattering of distant stars caught within a dark blue universe, giving the stone a celestial quality that has inspired poets and kings since the time of ancient Egypt. Now, let your mind travel from the cool depths of the night sky to the warm, sun-drenched sands of a desert here in the quiet heat of the arid earth. Another legendary stone is born, turquoise. This stone carries the colors of the horizon, where the bright blue of the sky meets the dusty greens of the landscape. Turquoise forms in dry regions through a very slow and gentle process. It happens when water, perhaps from a rare desert rain, seeps down through the earth and reacts with copper-rich rocks. As the water evaporates in the dry air, it leaves behind these vibrant, colorful deposits in the cracks and crevices of the stone. The specific shade of a piece of turquoise tells the story of the chemistry of the ground where it grew. If the stone is a bright robin's egg blue, it means there was a high concentration of copper present during its formation. If the stone leans more toward a soft, leafy green, it is because iron has found its way into the mix, subtly shifting the hue. Both variations carry a sense of peace and stability, like a cool spring in a dry land. These stones, with their rich, opaque colors, represent the intersection of chemistry and environment. They are the products of heat, minerals, and the slow movement of water through the Earth's crust. They feel solid and steadfast in our imagination, reminders of the enduring nature of the world beneath our feet. But as we continue our journey, we begin to leave the world of inorganic minerals behind. Not all treasures are born from the cooling of magma or the slow pressure of the mountains. Some of the most beautiful gems on our planet have a different origin altogether. They are created not by geology alone, but by the breath and pulse of life itself. Let us turn our thoughts now to the organic gemstones, treasures that have been grown and nurtured by the living world. Imagine a forest from a time so distant that the continents themselves were in different places. In these ancient woods, the air is thick and still, and the sunlight filters through a canopy of trees that no longer exist today. When one of these trees was wounded, perhaps by a falling branch or a hungry insect, it would release a thick, sticky liquid to heal itself, sealing the wound like a golden bandage. This is where our next journey begins, with a gemstone that isn't a stone at all, but a gift from the living world. This golden glowing substance is amber. It is a material that feels like captured sunlight, but its origin is often misunderstood. Many people believe amber is made from fossilized tree sap, but they are actually quite different. While sap is the thin, watery fluid that carries nutrients through a tree, amber is made from fossilized resin. Resin is a much thicker, stickier substance, produced by the tree specifically as a protective seal against disease and injury. It is the tree's own immune system turned into a beautiful, lasting treasure. For this resin to become the gemstone we recognize, it must endure a truly immense journey through time. It is not considered true amber until it has been buried beneath layers of earth and transformed by chemistry and pressure for at least several million years. Younger versions of this material exist, often called copal, but they lack the hardness and stability of true amber. It is the passage of millions of years that turns a sticky liquid into a solid window into the past. Because it is organic, born from life rather than the heavy minerals of the Earth's crust, amber is surprisingly light. If you were to hold a piece in your hand, it would feel much lighter than a pebble of the same size. In fact, amber is so buoyant that it can actually float in salt water. For centuries, people living along the shores of the Baltic Sea would walk the beaches after a heavy storm, looking for sea gold that had been churned up from the seabed and carried to the shore by the waves. But perhaps the most magical thing about amber is what it carries inside. As the sticky resin flowed down the bark of those ancient trees, it acted as a natural trap. It sometimes caught tiny travelers, a delicate gnat, a small beetle, a spider, or perhaps a fragment of a prehistoric leaf or a tiny extinct flower. These inclusions are frozen in perfect three-dimensional detail, offering us a clear window into an ecosystem that vanished long ago. To look into a piece of amber is to look directly back through the curtain of time. When you hold a piece of amber against your skin, you will notice something else that sets it apart from the cold crystals we have discussed. While a diamond or a sapphire feels icy and heavy, amber feels warm to the touch. It doesn't draw the heat away from your body. Instead, it seems to hold onto it, as if it still remembers the warmth of the sun that filtered through the leaves of its ancient forest home. It is a soft, comforting gem, a bridge between the world of plants and the world of stone. As we move from the golden warmth of the forest floor, we find ourselves drawn toward the cool, rhythmic sound of the waves. Just as the trees of the land created a treasure from their own life force, the creatures of the deep ocean have their own way of turning a small struggle into a thing of quiet, luminous beauty. Let us drift now from the ancient forests to the silent, dark blue world beneath the sea, where another organic gem is slowly and secretly taking shape. Imagine the weight of the water above you, a vast blue blanket that muffles all sound and movement. Down here, on the sandy floor of a quiet lagoon or a sheltered bay, the world moves at a different pace. In this silent world, nestled within the protective, calcified shell of a mollusk, like an oyster or a mussel, a small miracle of biology is taking place. Unlike the diamonds and sapphires born from the violent heat of the Earth's interior, this gemstone is born from a quiet, persistent act of protection. A pearl begins not with a grand event, but with a reaction to a small intrusion. We often hear that a grain of sand starts the process, but more often it is a tiny piece of organic matter or a microscopic traveler that finds its way into the soft tissues of the mollusk. To protect its delicate body from this irritant, the mollusk begins to wrap the intruder in layer after layer of a smooth, iridescent substance known as nacre. It is a slow, rhythmic process of coating and smoothing, a whisper of a gesture repeated thousands of times over many years. If we were to look at this nacre through a powerful lens, we would see that it is a masterpiece of microscopic engineering. It is composed of incredibly thin, flat flakes of a mineral called aragonite, which is a crystalline form of calcium carbonate. These tiny flakes are stacked like bricks in a wall, but they are held together by a natural, flexible protein glue called conchiolin. This combination of hard mineral and soft protein makes nacre incredibly strong and resilient, protecting the soft creature inside from the outside world while creating a surface of unparalleled smoothness. It is the way these layers are stacked that gives the pearl its soul. As light enters the surface of the pearl, it doesn't simply bounce off. Instead, it travels through these translucent layers of aragonite, reflecting and refracting off the edges of the tiny flakes. This creates a unique, shimmering glow known as the orient or luster of the pearl. It is a soft, deep light that seems to come from within the stone itself, a gentle radiance that shifts and dances as the pearl is turned in the light. This luster is the hallmark of a fine pearl, a visual record of the years the oyster spent carefully building its treasure. In the wild, the birth of such a beauty is an extraordinary stroke of luck. A natural pearl, one that forms entirely on its own without any human intervention, is vanishingly rare. For centuries, divers would search through thousands of shells just to find a single perfect orb. Because of this rarity, almost all the pearls we see today are cultured. This means that a human has gently invited the mollusk to begin its work by placing a small bead or a piece of tissue inside. The process that follows, however, is entirely natural. The oyster still spends years in the dark, quiet water, carefully depositing layer after layer of nacre, working with a patience that we can only imagine. Take a slow, deep breath now, and let your mind settle into that calm, dark water. There is no wind here, no noise, only the steady, rhythmic pulse of the tides far above. The ocean is a place of immense patience. It doesn't rush the oyster, and the oyster doesn't rush the pearl. Everything happens in its own time, layer by microscopic layer, in the perfect stillness of the deep. Feel the coolness of the water around you, the gentle weight, the silence, as we prepare to return to the world of stone, looking closer at the tiny secrets hidden inside the gems of the earth. As we leave the quiet depths of the ocean and return to the solid, ancient embrace of the earth, we find that even the clearest, most perfect-looking gemstones carry secrets within them. In the world of gemology, these internal features are often called inclusions. To some, they might seem like flaws, but to those who listen to the story of the earth, they are more like the fingerprints of nature herself. Each one is a unique signature, a tiny frozen record of the very moment that stone was coming into being. An inclusion is simply a material, a bubble of gas, or even a tiny drop of ancient water that became trapped inside a crystal as it grew. Imagine a crystal forming slowly over thousands of years, atom by atom. Occasionally, a tiny grain of a different mineral might land on its surface, or a microscopic pocket of liquid might be caught as the crystal lattice closes around it. These inclusions are like small time capsules, preserving a piece of the world as it existed millions of years ago, held safe within a transparent walls of stone. Some of the most beautiful inclusions are known as needles of rutile. Rutile is a mineral that often forms long, slender crystals that look like delicate threads of gold or silver. In certain types of quartz or sapphires, these needles can be seen clearly, looking as though someone has captured a handful of sunlight or straw inside a block of ice. They are incredibly fine, sometimes so thin they are almost invisible to the naked eye. Yet they add a depth and character to the stone that is entirely unique. When these needle-like inclusions are very fine and densely packed, gemologists call them silk. This silk is so delicate that you cannot see the individual needles. Instead, they create a soft, velvety glow within the gemstone, catching the light and scattering it in a way that makes the stone seem to shimmer from the inside out. This is often seen in high-quality rubies and sapphires, giving them a rich, sleepy depth that a perfectly clear stone simply doesn't have. It is a reminder that beauty often comes from the complexity of what lies beneath the surface. Sometimes these internal needles are arranged in a very specific, symmetrical way, following the internal geometry of the crystal. When light hits these needles, it can create a spectacular visual effect known as asterism, or the star effect. This is how we get star sapphires and star rubies. When you move the stone under a single light source, a bright, six-rayed star appears to float on the surface of the gem, dancing and gliding as the stone turns. It is a magical sight, a little piece of the night sky captured forever in a heavy, cool mineral. Beyond their beauty, inclusions are incredibly important to scientists. They act as a thermometer and a barometer of the ancient earth. By studying the minerals and fluids trapped inside, geologists can determine exactly how hot it was and how much pressure was being exerted hundreds of miles below the surface when the gem formed. These tiny fingerprints tell us about the movements of the continents and the cooling of the Earth's crust. They are a bridge between the present and a past, so distant we can barely imagine it. Take a slow, deep breath now and imagine yourself shrinking down, becoming small enough to wander through the corridors of a crystal. Imagine the soft glow of the silk around you and the golden threads of rutile reaching out like the branches of a quiet, frozen forest. It is a world of perfect stillness and ancient memory, protected by the weight of the earth above. As we move on from these tiny hidden signatures, we begin to look toward even larger hidden spaces, hollow wonders where entire worlds of color wait in the dark, silent and undisturbed. In the quiet darkness of the earth, there are so hidden rooms that no human eye was ever meant to see. These are the geodes, secret worlds tucked away inside what appear to be ordinary, unremarkable stones. From the outside, a geode looks like nothing more than a lumpy, dusty rock, perhaps a bit rounded or egg-shaped. It sits in the soil or embedded in a cliffside, blending in perfectly with the rubble around it. But if you were to crack it open, you would find a hollow heart lined with a shimmering forest of crystals, a miniature cathedral of light that has been growing in total silence for millions of years. A geode is essentially a hollow rock with a lining of crystals. They begin their lives as empty spaces or voids within the earth. In volcanic regions, these voids are often gas bubbles that were trapped in molten lava as it cooled and hardened. Imagine the earth once boiling and churning, and then, as it settled into a peaceful sleep, these bubbles remained frozen in time. In other places, geodes form in sedimentary rock, where a hollow space was created by a decaying tree root, a buried shell, or even an abandoned animal burrow from a long-lost era. These empty pockets become the cradles for something beautiful. The transformation happens with the help of water. Deep underground, mineral-rich water seeps through the porous outer rock and into the hollow cavity. It is a process of incredible patience. As the water evaporates or moves on, it leaves behind a tiny, microscopic layer of minerals, often silica or calcite, along the inner walls of the bubble. Drop by drop, year by year, these layers build upon one another. If the conditions are just right, the minerals begin to organize into perfect crystalline structures, growing slowly inward toward the empty center. It is a rhythmic, steady heartbeat of growth, occurring in a place where time seems to stand still. To protect this delicate internal world, the geode develops a very tough outer shell. This shell is usually made of chalcedony, a type of quartz with crystals so small they are invisible to the eye. This dense, stony layer acts like a suit of armor, shielding the growing crystals from the immense pressure of the surrounding earth. It ensures that the hollow space remains open, allowing the crystals the room they need to stretch and form their sharp, geometric points. Without this tough chalcedony rind, the weight of the earth would simply crush the hollow bubble before the beauty inside could ever form. While many geodes are small enough to hold in the palm of your hand, nature occasionally creates them on a scale that is truly breathtaking. In certain parts of the world, massive amethyst cathedrals are found. Geodes so large that a tall human could step inside and stand comfortably. Imagine the stillness of such a place. If you were to stand within one, you would be surrounded by thousands of deep purple amethyst points, each one reflecting the softest glimmer of light. It would be a world of perfect, cool silence, a sanctuary of stone that has never known the wind or the sun. These hidden wonders represent the peak of geological patience. They are the Earth's private treasures, kept safe in the deep, dark layers of the crust. But the story of a gemstone does not end in the darkness. The same Earth that creates these masterpieces also has a way of revealing them. Very slowly, the mountains begin to shift, and the ground above begins to wear away. The long journey from the deep, heavy heat of the mantle to the cool, bright surface of a riverbed is about to begin. As we rest here in the quiet, let us think about that journey, the way the earth breathes, moves, and eventually offers its beauty to the world above, carrying its secrets from the darkness into the light. Imagine, if you will, the slow and steady movement of the world above. For millions of years, the gemstones have rested in the dark, held tight by the mountains and the deep crust. But the surface of the earth is never truly still. The wind, the rain, and the ice are constant, gentle sculptors. Over vast stretches of time, these forces perform a slow, patient work called erosion. Bit by bit, the towering mountains that once shielded these treasures are worn down. The stone that felt so eternal is ground into dust and washed away, slowly revealing the hidden pockets of crystals that were once buried miles below the surface. It is a process that takes no shortcuts, moving at the pace of the ages. As the surrounding rock crumbles, the heavier gemstones are released from their stony cradles. Because gems like sapphires, rubies, and diamonds are incredibly dense and hard, they do not break easily. Instead, they are carried away by the flow of ancient rivers. They tumble along the riverbeds, settling into the silt and gravel in places geologists call alluvial deposits. It is a quiet, rhythmic journey. The weight of the gemstones causes them to sink, gathering in the bends of the river or at the base of waterfalls, where they wait in the cool, dark mud. During this long journey through the water, a beautiful transformation occurs. The constant movement of the river, the tumbling against sand and other stones, acts as a natural tumbler. The sharp, jagged edges of the rough crystals are slowly worn down. Over centuries, the river polishes these stones into smooth, rounded pebbles. A sapphire that began its life as a sharp, hexagonal prism might end up as a soft, translucent blue orb, its surface matte and frosted by the touch of the water. It is a testament to the power of gentle, persistent movement. These stones carry the memory of the river song in their smooth, cool shapes. While many gems are found in these riverbeds, others are discovered in unique geological formations called pegmatites. These are special veins of rock that represent the very last parts of a body of magma to cool down. Because they cool so incredibly slowly and are rich in water and rare elements, pegmatites provide the perfect environment for crystals to grow without being crowded. It is in these quiet, late-stage cooling chambers that we find some of the largest and most perfect crystal specimens on Earth. Huge pillars of beryl or quartz, sometimes several feet long and weighing hundreds of pounds, are born in these pockets undisturbed and pristine. These pegmatites are like the final concentrated essence of the Earth's creative power. They hold the purest expressions of geometry and color, waiting in the cooling veins of the crust until the slow dance of the tectonic plates brings them closer to the light. Every stone we find on the surface has a story of travel, a long, unhurried passage from the crushing heat of the depths to the cool open air. As we ponder this journey, we can feel the deep, steady pulse of the planet, a cycle that moves far beyond our own sense of time, preparing the way for the stones to eventually return to the earth once more, beginning the great circle again. As we have followed the journey of the stone from the crushing depths to the sunlit riverbanks, we find that every journey eventually has its return. Just as we find our way back to the quiet of our beds at the end of a long day, the earth has its own way of bringing its treasures back home. It is an eternal cycle, a slow and rhythmic breathing of the planet that mirrors the calm rise and fall of your own breath. This is the great circle of geology, where the end of one story is simply the quiet beginning of another. Eventually, the very ground we walk upon begins a slow, inevitable descent. Through a process called subduction, the massive tectonic plates of the earth slide beneath one another, carrying the rocks, the minerals, and the gems they hold back down into the warmth of the mantle. Here, in the intense enveloping heat of the deep interior, the stones lose their rigid shapes. They begin to melt, dissolving back into the glowing molten magma from which they were first born. These rubies, emeralds, and sapphires become the raw materials once again, the liquid potential for future crystals that may not grow for another 1,000,000 years. This is how the earth sustains itself, in a patient and tireless process of renewal. For over 4 billion years, our planet has been recycling its crust, folding the old into the new over and over again. It is a testament to the Earth's incredible patience. Nothing is ever truly lost. It is simply transformed, waiting for the perfect alignment of pressure and temperature to become something beautiful once more. The Earth is a master of this quiet work, never in a hurry, always creating in the deep, restorative dark. When you hold a gemstone in your mind's eye, you are looking at a tiny frozen moment of Earth's vast and ancient history. Each crystal is a captured memory of a specific time, a specific heat, and a specific pressure that will never occur in exactly that way again. And yet, for every stone that reaches the surface to be found, there are countless more that remain hidden. Deep in the lightless caverns and the heavy veins of the mantle, the crystals remain silent, still, and perfect. They do not need to be seen to exist. They simply are, resting in the peaceful cradle of the earth, much like you are resting now in the comfort of your room. As the world outside grows dim and the air around you becomes still, let yourself sink into that same sense of timelessness. You are a part of this great slow cycle, a quiet observer of a world that moves with the grace of mountains and the patience of stars. There is no rush, there is no tomorrow to worry about just yet. There is only the soft weight of your blankets, the steady, comforting beat of your heart, and the deep, restorative dark. Let the stories of the stones fade into the background of your mind. Let the sharp geometry of the crystals soften into the gentle, hazy curves of sleep. The earth is holding its treasures in the dark, and it is holding you, too. You are safe. You are still, and you are exactly where you need to be. Sleep now, in the quiet, in the deep, in the peace. Good night.